Okay, so this is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate, but please don't share personal information like contact info or social media tags in the chat box for your own personal protection. Okay? So we should have our attendance ticket open now. Again, link is in the chat box. Password is there as well. I need green checks all around if you have that open and ready to go. So let's see here. Adrian and Adriana, Ariana, green checks please. Dalen, and let's see here. Haley, Jackie, Jasmine, Jeremy. Thank you, Tucker. Johnny, waiting on you. Joshua, Julia, Kyrie, Kevin, and Rachel, and Saul. And Ty, green checks, please. Looking good. Thank you so much. Looking good. Hi, Charles. Welcome to class. Go ahead, open up your ticket, please. Got here just in time. Looking good, guys. Okay, so please remember that if you are a new student, attendance is 10% of your grade, but you can only get the attendance through the attendance tickets, and you only get those passwords if you're actually in class, right? So since I only provide the password in class, if you're here in person during the live class, you have to be coming in order to be able to get into those attendance tickets, right? If you ever have something like a doctor's appointment or if something's going on with your family, please let me know. We can work around that, or if you have a job or something, let me know that. But again, no, you have to have an excused reason, right? Cool. All right. So today, hey, what are you doing? Go back. So today we are working on the Unit 2 game day. All right. So today is right. We have our regular attendance ticket, but we also have extra credit opportunity today by participating in today's game. Dalen, my favorite food is bacon, but I mean, I'm a big fan of a lot of foods, right? I like sushi, I like pho, I like ramen, made some Salvadorian tamales yesterday. Those were delicious. Yeah, I like a lot of different kinds of foods. I like deep dish pizza. I'm from Chicago, so that's a big favorite of mine too. And Portillo's hot dogs. I don't know if you guys have been to Buena Park, but there's a Portillo's there, which is a very popular restaurant in Chicago. Pozole, yeah, pozole is delicious too. Okay, Zoe, just go ahead and email me and I can get you caught up, okay? Thanks for letting me know. But email me, otherwise I will forget. Okay? I have no memory, guys. Cool. All right. So today again we have that Unit 2 game day. Tomorrow we'll be starting Unit number 3. So again, it's going by quickly. We're in week 3, we're in Unit 3. So it goes by fast. Um Please remember that if you are a student who just started yesterday, when you look in your grade book, you'll know that because it will say that you're excused from week 1 and week 2 assignments. You'll see a bunch of excused marks, okay? Again, that's only if you actually started yesterday. If you didn't start yesterday, you're not going to see any assignments excused because you've been here for these 2 weeks, okay? But if you are a new student, please be aware that you do have a survey to do today. It's called the Welcome to Physical Science Survey. It's super short, and the only reason I gave it to you today instead of yesterday is because we don't have any assignments due today, right? We have our attendance ticket, but we don't have like a quiz or a lab or anything. So you have a little bit of extra time today. Do the survey, okay? Yeah, exactly. So pizza in Chicago is deep dish, right? So it's super thick. It's like 3 inches thick and delicious and cheesy. Yes, exactly. Cool. All right. Again, we saw at the beginning of class when we were giving each other helpful tips on how to pass the class. You got to do your labs, right? Labs are 25% of your grade, which means if you don't do the labs, you're automatically the highest grade you could possibly get is like a 75%, and that's only if you do everything perfectly, which we know, right, that it's not realistic to, right? But that being said, if you do the labs, it's definitely helpful, right? Because labs and quizzes together make 65% of your grade. Okay, smiley faces if that makes sense. I do have most of you have already completed your Star 360 as well, so give each other a round of applause for doing that. Right? That's amazing that you've already done your Star 360. But I do have like a fourth of you that haven't yet done Star 360, so please make sure you get that done. It's super easy, doesn't take a lot of time, and you get like 50 points, 10% of your grade from that. So that's super helpful as well, right? Just think of it like it takes you an hour to get an awesome part of your grade. Okay, so make sure you get that done as well. And again, we had a lab due yesterday, so if you haven't done it yet, make sure you get it done, okay? I haven't graded them yet, obviously. It takes me a while to grade them, but I will be getting zeros in by Friday, so if you haven't done those, you will see your grade drop. So make sure you do your lab. All right, guys, so we've been talking about phase changes and the states of matter. We've been talking about heat and energy and thermodynamics. That is what we looked at during this unit. So here's what's going to happen. Today is an extra credit game day. Okay, again, you have your attendance ticket open. We will be working on the attendance ticket later, right? But right now we're going to go ahead and actually play this Kahoot game. So if you're a new student, all you need to do is either in a phone browser or a computer browser, either one, you want to go to kahoot.it. That's the website. Smiley faces if that makes sense. Go to kahoot.it. Okay, and when you go there, you're going to see a screen that asks for a game pin. Okay, I will give you the game pin in a moment when we start our game. Obviously, I need to start the game before you can get the game pin. And then all you need to do is it's going to ask you for your name after you enter the game pin. Make sure you do your real name, right? So please put your first name and your initial from your last name. Don't put your full last name just because of security reasons, right? So just your first name and the initial of your last name. Smiley faces if that makes sense. Cool, cool. And obviously don't use any inappropriate names because A, you won't get your extra credit, and B, right, I'll have to refer you to admin and I don't want to do that. Takes too much time and it's not fun for you, not fun for me. Okay, and then from there you should be ready to play. Now remember, especially for new students, I give you extra credit as long as you participate. So make sure you answer all the questions. That way I can see you're doing your best, you're participating, you'll get your extra credit. It does not matter if you get a few questions wrong. That's totally fine. We're learning from our mistakes, we're getting better, right? Sally, I'm going to put it in the main chat box. Okay, here we go. So remember, just do your best, okay? Again, as long as I see you answer most of the questions, you'll get your extra credit. If you only answer like 1 or 2 questions, though, you're not going to get extra credit. You got to participate in the entire game. And the one last thing is, if you ever find that you can't come to live class, unfortunately, for future extra credit game days, I can't give you extra credit, obviously, okay? You have to be here on the game days because it's a game, right? So I can't make any exceptions to this. The only reason I say this is because it is just extra credit. It's not a mandatory grade, okay? So you can still do extremely well in the class as long as you do your other assignments. So if you ever miss a game day in the future, just realize you won't be able to get that extra credit back, okay? Cool. Thumbs up, everybody, if that makes sense. Thumb down if we're confused about anything. Okay, if you have any issues with Kahoot working, please let me know. I can open a private chat for you and you can work in the private chat. But again, try your phone, try your computer browser. It should work probably in one or the other one, okay? So I'm going to go ahead, I'm going to turn off my video and I'm going to go ahead and get the game set up. All right, let's go ahead and get this going. So opening this up right now, get ready to go. Again, you're going to enter your first name and the initial of your last name. So I'm sharing this with you right now. Okay, smiley faces if you can see my whiteboard here. Smiley faces if you can see my whiteboard. Yay, awesome. Okay, so let's make sure I have all my settings correct. Awesome, here we go. All right, all right, all right. Give it a moment to load. And here we go. Again, password's kahoot.it. It does mention there is an app, but the pin you're entering is 6500756. Yes, Eva, here you go. Here it is. Okay, okay, hold on guys. This is freaking out. I'm going to stop that. I think I need to clear my cache. Hold on one second. Sorry guys, I don't know why Kahoot keeps on freaking out on me like that. Let's try that again. Nope, still doing that. Okay, sorry guys, 1 second. Let's try this one. All right guys, hold on. Let's try this one. All right guys, sorry, try this one. All right guys, there we go. Go ahead, get up there. Again, first name, last initial, first name, initial of your last name. Looking good. Awesome. Look, it's got a little Thanksgiving theme. Or a fall theme, I guess. Pumpkin pie, some leaves there. I like it. Awesome, awesome, awesome. I have like 40 of you, so I want to at least see like 30 of you up here so that I can go ahead and get started. You can still join at any time, right? Just obviously don't wait too long because then you won't get any points. Look, fall leaves, I like it. Oh yeah, there's a pie, I like it, Zoe. Looking good. A little drumstick. Kyrie is apparently vomiting. I don't know how I feel about that. Sienna. Cool. All right, guys. Let me know if you're having any issues. I'm going to get us started in about 20 seconds. Get your name up there. Again, if you're having any issues, let me know. I'll open up a private chat for you. Okay, looking good. I see Angelina. Perfect. Little kitty cat. Oh, look, another cat here. Awesome. 10 more seconds, and then we're going to get started. Again, the only way you get your extra credit today is if you're actually in the game and participating. If you're just sitting there, you don't get extra credit. Okay. And let's go ahead and get started. Perfect. Are we ready to rumble? All right. In which state of matter are the particles moving the fastest? Gas, solid, or liquid? Gas, solid, or liquid? Looking good. 20 seconds. Awesome, Dalen. I see your answer in the chat box. Let me go ahead and write down your name so I remember that you are in the chat. So you still get your extra credit for today. If I can find my pen. 2 seconds. What's today's date, guys? The 14th? Good. All right, yes, gas. In a gas, the particles are moving the fastest. Awesome. Tucker in the lead, Annalise following, Kim in third. So that means in which state of matter are the particles moving the slowest? Which one are they moving the slowest? If they're fastest in gas, where are they slowest? 15 seconds. Okay, Elisha, if you need to, you can answer your questions in the private chat I just opened, okay? So here, I'm opening it for you now. Okay. That way you can still get your extra credit. As long as you answer in the private chat, you'll still get your extra credit. Cool. Yes, in a solid, they are therefore the slowest. They are therefore the slowest. All right, smiley faces, guys, if that makes sense. All right, hold on 1 second. I'm just writing down all the kids who are in private chats. Pen work. Looking good. All right, so let's go ahead and go over this really quickly. Jonathan's still in the lead. Let's make sure that this makes sense. All right, guys? So remember here, okay, solids, the molecules are vibrating in place. They're moving very slowly. That's why they're a solid. Liquids, they're moving a little faster. They're sliding past each other. Gas, they're moving the fastest. They're bouncing away from each other. They're trying to escape. Let me know if that makes sense. Awesome, guys. All right, let's keep on going. So liquids. Liquids. Do they have a definite shape and definite volume or amount? Do they have an indefinite shape and a definite volume or amount? Or an indefinite shape and an indefinite volume / amount? Okay. What do we think? Think carefully about how liquids work. Do they stay the same shape? Do they change shape? Do they stay the same amount, the same volume? Think about like teaspoons of liquid. Does it stay the same amount? Yes, guys. So in this case, they have an indefinite shape, right? Liquids can change shape, and they have a definite volume or amount, which means if you have 1 cup of liquid, it's going to continue being 1 cup of liquid, no matter how much you move it around. Okay, smiley faces if that makes sense. Liquids. Smiley faces if that makes sense. Oh my gosh, Annalise in the lead for now. Jonathan in second. Let's see if Jonathan can get it back. Let's make sure this makes sense, guys, okay? So let's take a look at that. Again, a liquid does not keep its shape, right? It can spread out depending on the container it's in, right? Indefinite shape, but it has a fixed volume. If you have 1 cup of liquid, it's going to continue being 1 cup of liquid. Just want to mention really quick, guys, that a solid has a definite shape. It stays the same shape, and it also has a definite volume. It stays the same amount. Gases have indefinite shape, right? They can change shape, and they also have indefinite volume. They can actually spread out, and they can cover more surface, more area, okay? Cool. Let's go ahead and keep on moving. So, exothermic means exo. Think what exo means. Does it mean heat exits a substance or heat goes into a substance? Exothermic. What does exothermic mean? Use your context clues. Think about what the prefix exo means. 15 seconds. Again, if you are one of my chat people, make sure you answer, please. Elijah, Dalen, and Seha, make sure you let me know in the chat box. Oh no! 5 seconds. Okay, exothermic means heat exits. The word exo actually means exits, right? So heat's going to leave a substance. It's going to go away from the substance. The substance is going to get colder, okay? The substance is going to get colder, okay? Oh no, 3 players dropped their answer streak. That was a tough one. Okay, let's make sure that this makes sense. Oh, Haley, that doesn't sound like a situation where you need help. So again, exothermic means it releases heat. Heat exits. Endothermic, on the other hand, means heat goes into. Endo into, exo exit. Endo into, exo exit. Let me know if that makes sense. Looking good. Elijah, if you're in the chat box, make sure you let me know. Cool, cool, cool. All right, let's see. Oh, Annalise in first, Destiny in second, Stephen in third. Let's see what happens now. Melting, going from a solid to a liquid, is a what? Exothermic, heat exits it, or endothermic, heat goes into it. Think about a liquid. Is a liquid hotter or colder than a solid? Hotter or colder, heat added. Oh no, yes, this is going to be endothermic. Heat goes into it, right? Liquids, are they hotter or colder? Tell me in the chat box. Are liquids hotter or colder? Yes, liquids are going to be hotter than solids, right? Liquid water is hotter than ice, right? So liquid's going to be hotter, which means it's got to be getting heat. So heat must be going into it. It's endo, into endo, into endo. Awesome. All right, Destiny in the lead, Stephen following. Sophia takes third. Condensation, going from a gas to a liquid, though, is a what? Is it endothermic, heat going into it, or exothermic, heat exiting, right? Gas to liquid, think about it. Is a liquid hotter or colder? If it's hotter, heat's going in. If it's colder, heat's exiting it. Hotter or colder? Think about that. Awesome, awesome. Elijah, I see your answer. Dalen and Seha, make sure I see yours. 5 seconds. No. Yes, this one is actually going to be exothermic, guys, okay? So again, gas to a liquid. Is a liquid hotter or colder? Is liquid hotter or colder than steam, for example? It's colder, right? So if it's colder, it must be losing heat. Heat must be exiting it. Smiley faces if that makes sense. It's colder, so heat's exiting. Awesome. All right, Sophia in the lead, Stephen in second, Sally in third. Let's make sure this makes sense. All right, again, condensation, deposition, they both get colder, and so that's exothermic, right? Heat's exiting. Sublimation, evaporation, they both get hotter, so heat must be being added. Endothermic, going into. Okay, let me know if that makes sense. Love it. Looking good. All right. Deposition. Deposition. Is this solid to gas like dry ice or gas to solid like frost? Think about deposition, sounds like deposit. Deposition sounds like deposit. 10 seconds. Awesome. Say hi. I see yours. Elijah, I see yours. Dalen, make sure I see yours. Thank you. I see yours. 3 seconds. This one is actually gas to solid, guys, okay? So remember, deposition means it deposits onto something, right? So think about how water deposits frost onto leaves when it goes from a gas in the air to a solid ice on the leaves. Smiley faces if that makes sense. Do you guys remember what a solid to gas is called when we have dry ice? It starts with an S. Do we know what that's called? It's another big word. We'll typing. It's sublimation. Sublimation. Yes. Awesome, Jonathan. Tucker. Awesome, Seha. Sophie in the lead. Stephen in second. Sally in third. Let's make sure this makes sense. All right. Deposition, going from a gas to a solid. We're getting colder. We're releasing heat. We're exothermic. Sublimation, like dry ice, is going from a solid to a gas. We're absorbing heat, getting a lot hotter. Endothermic. Let me know if that makes sense. How old is your puppy, Haley? What kind of dog is it? Awesome, guys. All right, let's keep on moving. When molecules collide, do they transfer energy, delete energy, or create energy? When molecules collide, do they transfer, delete, or create energy? 3 months and a Chihuahua. Oh, man. That's cute. Chihuahuas are so cute when they're puppies because they're just so tiny. Awesome, Elijah. I see yours. Dalen, Seha, make sure I see yours. 5 seconds left. Remember, guys, just guess. If you're not sure, just guess because you want to get your extra credit. As long as you're doing your best, you'll get your extra credit. Yes, they transfer their energy. Remember that energy can neither be created nor destroyed. So the only option is to transfer it, like billiard balls, okay? like when you're playing pool. Okay, so Sophia in the lead, Steven in second, Sally in third. Let's make sure this makes sense. Tucker on the leaderboard. Yes. So when molecules collide, they cannot gain or lose energy. They can just transfer it, right? Just like when one ball hits another ball, it just transfers the energy from one ball to the other. Awesome, guys. 5 seconds. Looking good. All right. More collisions of molecules against a container wall results in no effect on pressure, less pressure, or more pressure. Think about collisions against the container wall. If molecules are colliding more, what's happening to the pressure? Awesome, Dalen. I see yours, Seha. 10 seconds. Elijah, make sure I see yours in the chat. 5 seconds. In this case, it's definitely going to be more pressure, right? Collisions are pressure. The more collisions there are, that means the more force against the wall of the container, more pressure, right? So as we, for example, heat up a gas container, right, those collisions speed up. We get more collisions, more pressure until what happens? What's going to happen to that gas container if we heat it up too much? If there's a lot of pressure, what's going to happen? Yes, it's going to blow. It's going to burst or explode. Yes. All right. Sophia in the lead. Let's see here. Does this make sense? All right. Again, more collisions, more pressure, right? So as we collide against container walls, that is pressure. So more collisions, more pressure. Let me know if that makes sense. Yeah, kablamo. Exactly, Tucker. Love it. Looking good. All right. The first law of thermodynamics states that the energy before is the same as the energy after, is more than the energy after, or is less than the energy after. First law of thermodynamics. What does it tell you about energy? Awesome, Seha. I see your answer. 5 seconds. It's going to be the same as, remember, conservation of energy, that is the first law of thermodynamics. And conservation of energy says you never have more energy, you never have less energy. It's always in total the same amount. Always in total the same amount. Steven in the lead. Oh my gosh. Sally in second, Sophia in third, Annalise in fourth, Tucker in fifth. And 3 players lost their answer streak. Oh no. So sad. Let's make sure this makes sense. All right, so conservation of energy, energy can change, but it's never created or destroyed. The amount before is the same as the amount after. Even if it's different, it's still the same amount. Still the same amount. Looking good, looking good. All right, so when energy changes, the amount of usable energy, does it stay the same, increase, or decrease? Okay, so we already know the total amount stays the same, but what about the actual usable energy? Does it stay the same, increase, or decrease? I love the competitive spirit. Looking good. Dalen, Seha, Elijah, make sure I get your answers. Again, if you're not sure, guys, just do your best. Yes, it actually decreases, okay, guys? So when we talk about usable energy, we mean energy that we can actually reharness and continue to use, right? So an example of unusable energy is heat, right? So a lot of energy gets lost as heat, and we can no longer use it, okay? So even though the total amount is the same, the amount of usable definitely goes down. Awesome. Steven's still holding on to lead. Rachel making a comeback. So, second law of thermodynamics states that as energy changes the entropy or disorder, the amount of disorder, does it stay the same, increase, or decrease? The amount of disorder. Think about the world, think about your room, right? If things just happen spontaneously, disorder, what? Stays the same, increases, or decreases? 5 seconds. Oh man, oh man. Entropy increases. Disorder in the universe is increasing. That is why everything dies. That's why batteries don't spontaneously recharge. That's why water falls. It doesn't go up, it goes down. Things go down. They get more and more disordered. Okay, Jonathan in the lead. Oh man, Steven in second. Let's make sure that this makes sense. All right, guys. So, second law says entropy, the amount of disorder increases because as we change, we're losing usable energy. So some of that becomes unusable, meaning there's more disorder in the universe. Okay, some of that becomes unusable. There's more disorder. Okay, so less usable energy, more disorder. Okay, sorry guys, I just want to show that one more time. There's less usable energy and more disorder. Smiley faces if that makes sense. Okay, less usable, more disorder. Usable energy decreases, disorder increases. Awesome, cool. All right, let's see if we can catch up to Tucker. So, third law of thermodynamics states that absolute zero is when what? Motion speeds up, all motion stops, motion is not affected by temperature. 10 seconds. Again, if you're not sure, just do your best guess so that you get your extra credit. Don't worry if you make a mistake. We're going to learn the correct answer anyways. Awesome, Elijah. I see yours. Dalen and Seha, make sure I see your answers, please. Yes, this is when all motion stops. Absolute zero means there's no heat, means there's no energy to move. All right. Sarah is the highest climber. Loving it. Let's see. Does this make sense? All right. So again, third law, all motion stops at absolute zero. So this is 0 Kelvin, the moment at which all motion stops. Absolute zero. All right. Let me know if that makes sense. Cool. All right, guys. That being said, guys, can we actually reach absolute zero? Can we actually get to absolute zero currently? With our scientific understanding, can we actually get to absolute zero? No, right? Because remember, to freeze something to absolute zero, we would actually need a freezer that's colder than absolute zero. So right now, we do not have the ability to get to absolute zero. We can get really close, but remember, because all atoms have some sort of motion, it's almost impossible, probably, for us to ever get to the point where there's no motion. All right? Cool. Tucker in the lead, Sophia in second, Steven in third. Steven, you gotta catch up. You gotta, follow up your words with catching up, right? All right, the amount of heat needed to change a liquid to a gas is called the what? Heat of fusion or heat of vaporization? Again, liquid to gas. Liquid to gas. You gotta put your money where your mouth is, Steven. Come on. 20 seconds. You did. You were doing very well, Steven. You're still doing very well. 10 seconds. Awesome. Say hi, Elijah. I see your answers. This one is actually the heat of vaporization. What do you guys notice about the word vaporization? What does it have in it? What word does it have in it? Yeah, it has the word vapor. So vapor literally means like a gas, right? So liquid to a gas, we're vaporizing it. Smiley faces if that makes sense. So the amount of heat we need to go from a liquid to gas to vaporize it is called the heat of vaporization. Cool. All right. So Tucker in the lead, Sophia in second, Steven in third. Let's make sure this makes sense. Again, heat of vaporization, we need to add this to change a liquid to a gas. The heat of fusion is changing a solid to a liquid. It's melting it, okay? So heat of fusion is melting, heat of vaporization is turning it into a gas. Cool, cool, cool. 5 seconds. All right. During a phase change, like melting, going from a solid to a liquid, or two phases existing together, does temperature increase, stay the same, or decrease? Again, I have a graph here that's helpful. So take a look. During a phase change, what's happening to temperature? During a phase change, what's happening to temperature? Oh no, Tucker! Yes, this was on the lab. You are correct, Sienna. This was the last question on the lab. Yes, temperature actually stays the same. Take a look at this, guys. Where are the phase changes? Are they the ones in purple or the ones in yellow? Where are the phase changes? Purple or yellow? Yes, the phase changes are the yellow parts. And do you guys see how this line is flat? Do you guys see that? Give me a smiley face if you see how this line is flat. Smiley face if you see that. I know, Sophia's doing awesome. Yeah, so because this line is flat, it means temperature is not changing. So all of that energy going into this part is not going into increasing temperature, right? All of the thermal energy is not increasing the temperature. Instead, all it's doing is causing the phase change. All it's doing is separating the solid molecules so that they're further apart and it turns into a liquid. Thumbs up if that makes sense. Thumbs up if that makes sense. Okay? All the thermal energy is not increasing temperature during phase changes, okay? Which is what we saw yesterday. We saw that when we have an ice and water together, it actually stays at freezing temperature until it's all liquid water. Only once it's all liquid water does that thermal energy begin to actually heat that liquid up, Okay, but while there's two things there, solid and liquid, it stays at 0 degrees, or if it's a liquid and gas, it stays at 100 degrees. Cool. All right. Let's make sure, does that make sense? All right, again, during a phase change, like melting, temperature actually stays the same. All the energy only goes towards breaking the molecules apart. Only once we're in a single phase do we begin to increase temperature. Okay, let me know if that makes sense. Looking good. All right, you guys got a couple more chances. Oh my gosh, are you okay? Good. All right, Sophia, let's see if we can catch up. When matter changes its state, solid, liquid, gas, what's actually changing? The way the molecules interact or the individual molecule? What is happening when matter changes state? What is actually happening? The way the molecules interact or the individual molecule? Think about ice, liquid, water, and steam. Is the molecule changing or is the way they interact changing? Awesome. It's the way the molecules interact. Remember, solid, liquid, gas, ice, liquid, water, and steam. Is it all H2O? Are all the molecules H2O? Yes, exactly. Their molecules are always the same. The only thing that changes is how they interact with each other. All right, let's take a look at this. Let's make sure this makes sense. Yes, so solid, right? The molecules vibrate in place very closely. Liquid, the molecules can slide past each other. Gas, the molecules can actually escape from each other. But the molecules are still always H2O. The molecules themselves stay the same. Let me know if that makes sense. Perfect. Looking good. Awesome. Give Sophia a round of applause for getting first on our leaderboard, and give everyone else a round of applause who made it up on the leaderboard. We got Tucker, Steven, Sally, and Kendra on the board. You guys did awesome. I'm going to download our results really quickly. Yes, you guys did amazing. All right, cool. So one more time, guys, here is your attendance ticket. You did awesome today.